Why does time move forward and not backward? Have you ever wished you could go back in time, reverse a mistake, relive a perfect moment, but no matter how hard we try, time always marches forward? Why? What if I told you the answer involves exploding stars, melting ice cubes, and even the birth of the universe itself? Welcome to one of the most mind-bending mysteries in physics. Why does time move forward, not backward? What do we mean by time moving forward? Let us start with what we observe in everyday life. You are born, you grow older, you die. An egg breaks but never unbreaks. You remember the past but not the future. This one-way direction of time is called the arrow of time. But strangely, most of the fundamental laws of physics like Newton's laws, Einstein's relativity or quantum mechanics do not care which direction time flows, they work the same forward or backward. So, if the laws of nature allow time to go both ways, why do we only experience it one direction? The secret in entropy explains us that nothing can be reversed once heat given to atmosphere can never be used for purposeful work. And the second law of thermodynamics states that the entropy of an isolated system either increases or remains constant in any spontaneous process. It never decreases. This means that in natural processes, energy tends to speed out and become less available for doing work, leading to an increase in disorder. Now comes the big idea. Time flows forward because entropy increases. Entropy is a measure of disorder, of randomness. Let us use a simple example. Drop an ice cube into a glass of warm water. Over time it melts. Cold becomes warm, structure becomes chaos. The system moves from solid ice to disordered liquid water. And here is the key. The second law of thermodynamics says entropy in a closed system will always increases over time. Closed system is that system which starts from one point and ends at that point, that is known as closed system. This is the only major law of physics that is not time symmetric. It creates preferred direction from low entropy to high entropy, from past to future. Think about memory. You remember the past because it had lower entropy, a more organized state like a library with sorted books. The future has not happened yet. Its books are scattered in randomness. So, time's arrow is not written in the equations, it's written in the universe increasing disorder. But why did entropy start low? Enter the Big Bang. Now the mystery depends. If entropy increases, it must have started very low. And that brings us to the beginning of time, the Big Bang. 13.8 billion years ago, the universe was unimaginably hot, dense, and astonishingly ordered, a low entropy state. But how could such a chaotic explosion be ordered? Because gravity was the key player. Gravity wants to clump things together, but in the early universe, matter was spread out almost perfectly evenly. That's actually a high ordered setup for a gravitational system, meaning low entropy. As the universe expanded, gravity clumped matter into stars, galaxies, black holes, and entropy exploded. So, time flows forward because the universe started in a bizarrely low entropy state, and entropy has been increasing ever since. Can time go backward? Time reversal in physics. Now, here is a twist. In quantum physics, reversing time mathematically is completely allowed. In some interpretations, particles can even go backward in time. Physicists have even reversed time temporarily in quantum simulations, but only in ultra controlled environments and for microseconds. It's not time travel, just a mathematical illusion. So, while time symmetry exists in equations, the macroscopic world ruled by thermodynamics and gravity prevents the backward flow of time. What if time could go backward? Let us imagine a world where time ran backward. Smoke returns to a cigarette. You grow younger, memories disappear, broken glasses unshatter, stars resemble into pristine clouds of gas. But for this to happen, entropy would need to decrease. That's like scrambling an egg and getting it whole again, astronomically unlikely. The universe is not designed to reverse entropy, and therefore it isn't designed to reverse time. Is time an illusion? Some physicists like Carlo Rovelli and Julian Barber suggest that time may not be a fundamental. In this view, the universe exists as a collection of noise, static moments. Our feeling of time flow is just how our brains interpret change. Time does not flow. We move through it like flipping frames in a film reel. So maybe time's arrow is not in the universe, it is in our minds, the cosmic clock. So why does time move forward and not backward? Because entropy increases. The universe started with low entropy, and we are tiny observers caught in the wave of rising disorder. Time as we feel it is the story of the universe losing its order slowly, relentlessly, beautifully. Maybe someday we will fully understand why time had to begin and why it can never turn around, and we cannot, it is not possible to reverse the time.